this rather manky looking thing is a negative ion generator that I built for my mum and dad a long time ago. It's when they first moved into the house in Isle of Man, and they had a little cupboard under the stairs it was always sort of dark and cold and damp, and it always smelt a bit musty. So I made them an ioniser for it. That the ionisers charge the air basically, and it means that any airborne particulate like mould spores and dust and stuff like that, it tends to precipitate out to the walls, and it just gets rid of it. Well, it doesn't get rid of it, it precipitates out, but what does get rid of a lot of this stuff in the air is the fact that ionisers like this produce a tiny quantity of corona discharge on the end of the needles, and that creates a trace quantity of ozone. Not a lot of ozone, just enough to actually just have an effect. It's a lot of so-called ionisers being sold these days on eBay are actually ozone generators, and they'll produce that bleachy smell, and they won't produce much in the way of ions. It's just what they do these days, and they just cash in the image that ionisers had. And I don't know what's been happening with this because it's all crusty. It's got stuff caked round it. I'm not sure what that is. Is it stuff that it's pulled out of the air and it's just built up over time because it's been a long time? So it's got a unpluggable emitter. Well, it was unpluggable. Look at the state of that. It's all corroded. And it's based on a standard banana plug, and it's got these needles in. They used to all point in a sort of little fan shape like this, so let's straighten them up and we'll give it a clean as well. And the advantage of this is that you can plug in probes for sort of ionic healing, where you can actually use a high voltage cable and a needle at the end, and it can actually project ions onto your skin or a cut or something like that and sterilise it. It was just what I built at the time. So let's take a look inside it and then I'll give it a clean up. Now my brother says he doesn't think it's working because the lights aren't lighting. Now this light in the front is a really dim orange one that pulses to show the output. And the one at the back, which he's probably looking for that one to light up, it's a blue neon, but it's so old that it's most likely just gone dim. I doubt the ioniser has failed in any way because it's pretty rare that an ioniser fails. So this was built completely from scratch. It was a custom circuit board that was just this ioniser, and that was it. And it's been potted in resin. Oh, that's a bit annoying because it makes it a wee bit harder to actually clean. I wonder why I did that. Potted in resin and then sprayed with its black proper potting compound. Oh, look at there's a bit of green verdigris actually. I suppose oxidised copper, which is verdigris right enough, that has just formed in there at the highest voltage point. I wonder why that particular one. Maybe it's because it's in the vicinity of some other connections. It's got the two high voltage output resistors. It's got the little blinking neon here that should have a little capacitor across it, which is probably buried or in the back of the... Maybe it's just actually that capacitor is just in series output. I'm not sure. It's a shame it's potted. The capacitors, the value of them, quite unreadable. It's 22 nanofarad, so a beefy little ioniser. And at this end it's got the resistor and the little blue neon, and it's been sprayed with that white paint just to make it sort of look brighter from the inside because it was obviously quite dull to start off with. So it's very clean inside, so that's not a great problem. So I'm going to give this a clean and then I'm going to check it out and see if those little indicators are working. So I'm just going to give it a really good clean actually, because it really needs it. It's manky. So while I was cleaning it, I decided I'll cut out the old dull blue neon indicator, which is it's gone kind of sooty and grey inside as they always do. And I'm going to replace that with an LED, and I'm going to use a bridge rectifier across the LED, and I'm just going to add another resistor in series. But I thought, while I've got it open, let's see how much current this actually consumes without the neon indicator. So I've jury-rigged this complete death trap. I wouldn't recommend this at home. It's electrically dangerous. In fact, if you're an official with the health and safety executive, you should thumb this video down right now just to teach me a lesson, because I'm a very naughty bear. Anyway, I have put the meter in series with this. I've connected it, turned it to AC amps, and now I'm going to just unleash the power on this ioniser. This is all live now, so I'm not going to touch it. And it's showing that while the ioniser is sitting on the bench with the needles in the vicinity of the sort of ground plane, so to speak, it's drawing about 90 microamps. And if I then move the ioniser so the needles are in the air, they're protruding over the edge of the bench, as would be the normal case with an ioniser, then the current then drops down to, well, if I step out of the way, because I'm probably acting as a ground plane in front of the ioniser, It's dropping down to about 60 microamps, and it will gradually just keep dropping down to about 55 microamps, which means that this unit draws less than 1/100th of a watt in normal operation. That's a fairly big voltage multiplier it's got in it compared to the normal ioniser. So I'll just make this, see, it's safe now. I'll just make this safe by lifting the lid on that. So this is using 22 nanofarad capacitors instead of the 10 nanofarad capacitors. It's actually got 30 capacitors and 30 diodes, but I was looking for the other capacitor for this neon indicator, and it's up here. It's just another of exactly the same capacitors, just tapped onto the end. So, yep. Right, I'm going to make that modification right now, and I'll be right back. So that's the unit all cleaned up now, and it's looking very shiny and new, and it's definitely putting out a good stream of ions. The neon indicator I replaced with an actual blue LED, which is running at 1/10 of a milliamp. It's running very low current because I'm just using I'm using the original resistor that fed the neon, plus I added another one because I didn't need as much current for this. And then I just tacked onto the existing neon's leads and used a bridge rectifier made from discrete diodes with basically a diode, an LED across it, so that no matter what the polarity, the current always goes through the LED. And the output, which isn't terribly visible because it is just a very dull neon, it has that little capacitor and resistor and neon circuit, so that as the potential difference changes, as the ions emit out the end, that capacitor, the voltage across it increases until the neon strikes over and then it discharges the capacitor. So it just fires tiny little dots of light, just to give you an indication of how active the output is. It is a frivolous gimmick, it's not needed. The voltage multiplier itself, I should add in there that those are 22 nanofarad, 630 volt capacitors. Actually, they're suppression capacitors. X2 is good enough, yeah, because you know they've got a fairly high DC voltage, and the diodes are 1N4007, which is a 1000 volt 1 amp diode. It's not being used anywhere near an amp. It's being used at microamps, but you know, to all intents and purposes, yeah, it's a cheap generic diode that just does the job. The output is two 1 megohm resistors, and the point of those is just a safety feature, because otherwise you could be touching, if you touch the output and those weren't there, then you'd be connected directly to the mains via these diodes, and you know, it depends. If it was connected, as in this case, to neutral, it wouldn't be such a hazard, but if it was connected to live through a non-polarized plug, it would be a hazard. So you have to have these resistors here, and they normally have a value of 1 megohm or 10 megohm. Ultimately I chose 1 megohm here for some inexplicable reason, but that's fine. It does mean you get a bit more of a snap off it static electricity wise. The capacitor diode arrangement, the voltage multiplier, which is called is it a Walton-Cockcroft or a Cockcroft-Walton? I can never remember, I keep getting those mixed up. But it's a very simple circuit whereby it relies on the changing polarity of the mains. So initially when this is negative and this is positive, then that capacitor will be charged up with that end negative and this end positive. And then when the polarity changes, it sort of pushes it up, and then it shuffles it backwards and forwards along the set of diodes and capacitors, and it's very simple. It multiplies the voltage each time. It just adds on a sort of peak rectified mains voltage, and the end result is you get much. It's not ideal for high current applications, but it is ideal for high voltage, low current applications like this. It's perfect for a multiplier. Now I have to say the 30 capacitors and diodes is for European 230 volts AC. If you're going to try something like this in America, you may have to use a transformer at this end to step the voltage up initially from 120 volt to 220 volt, 240 volt, whatever. And if you did that, one end of that would have to be connected across, or you could use an auto transformer, just so it's got a reference, because this end of the multiplier needs to be referenced to the ground, so the ions can actually, well, they're looking for ground. That is the whole point of it. It just creates a high negative voltage at the end with respect to ground. But the other option, if you're in a country with 120 volts, is that you could just use a really long multiplier. I've heard that it works. I've never tried it myself, I've never had to try it myself, but it means it gets a wee bit unwieldy. It means you get 60 capacitors and 60 diodes or something like that. Probably 50 would work, I don't know. It's something that maybe could be experimented with. But you'll know you're getting good results when at night time you can either see a very dull purple glow on the end of these needles, or you can actually hear it hissing, and you can feel, if you put your hand in front of it, you can feel a slight draft, particularly if you lick your hand, the back of it, and then put it in front, you'll feel a nice cold draft coming off onto your hand. They're very odd things. They just basically, because they create a high charge and they've got very sharp points, and the area of charge is most concentrated at sharp points, and it basically charges the molecules of air. It basically creates an electrostatic charge in the air, and then because the needles are negative and the air is now negative, it repels away and it creates a sort of ionic breeze from the end of it, and that carries a negative charge into the air with respect to ground, and it means that if any dust or contaminants in the air get negatively charged, then they automatically get attracted like a magnet to a grounded surface, and that's how these things work. That's why they always end up completely filthy, you know, really dirty. If you put them on a white surface and leave it for a week, then you know your ioniser's working. When you pick it up and there's a nice outline of your ioniser in white with a sort of slight shade of grey around it, that's the best way to test an ioniser for its effectiveness in removing dirt and dust and pollen. They're very simple, but they're actually very good. Now, I have to mention, I think I mentioned this before, did I? That many of the items sold as ionisers online are not ionisers. They're actually ozone generators, completely different beast, not the same thing at all. The best ionisers are the ones with sort of needles or carbon film emitters in the end that are actually putting the charge out into the air. But yeah, this one's now going back to Ralph, my brother, so it's all been refurbished. It's ready to serve for another 20 years, so good result.